Hello everyone, welcome back to my channel. So in today's lesson we are going to consider this graphical method. Of course, our previous video we talked about simultaneous equation, the three methods of simultaneous equation. That is, we have elimination method, substitution method, and the graphical method. So we have treated the two types, which is the two methods. We treated the two methods of this type of equation. And for today's lesson, we are only going to consider the last one, which is the graphical method. Of course, for graphical method, we are going to have two equations. We use these two equations. If we use a graph, we try to plot this type of equation. We use a trace of these lines in order to find the intersection of this line. So the intersection of this line is referred to as the solution of the equation. So you are going to see, in order for us to achieve this graphical method, there are three steps involved. So first, we need to have two equations. Of course, as you know, simultaneous equation works with two equations. So based on these two equations, so first we've got a straight line. A straight line, we can plot this graph based on the 2 points we have. So the first part of the equation, we plot a graph. Then we relate the first line of the equation to the second line of the equation. Then the intersection of this line is the equation. So let's see on the board here, I said what? A graphical method. We draw the graph of each line and trace out the intersection of this line. The intersection of the line is the solution of the equation. Okay? So here we have two pairs of equation that has two unknowns. Okay? We have two, that means x and y, or any letter you can use. You can either use a or b or m or n. So, but you must have two unknowns. So based on these two unknowns, we plot our graph. These two pair of equation that has two unknowns, we can plot our graph. So when we plot our graph, the intersection of these two lines is the equation. Okay? Is the solution of the equation. So here I said to solve simultaneous equation using graphical method, the following must be noted. So first here we say what? Draw the straight line, that is the straight line of the graph for each given equation. So for an example here, we have x plus y equals to 6. So first we try to draw a graph of this equation, this linear equation, then we find the intersection. So then the second point says, find the coordinates of the point of intersection. That's the coordinates can be either x or y coordinates, okay? So these coordinates, we'll find the intersection of these coordinates of the two lines we have drawn. So then the third point says, the point of the intersection is the equation. Okay, is the solution of the equation. So now on the board here we have two examples to solve. So the first one says solve the following equation using graphical method. So which says, the first one says x plus y equals to 6, and the other one says x minus y equals to 3. Then after which I'm gonna give you some time. You try to use the same method you solve this. You can pause the video, solve this equation, then after some time you can review again. We try to solve this one together. So first, let's see. This first equation says x plus y, solution. So the first equation here says x plus y equals to 6. So in this equation, we are going to make a table. Okay? We're going to make a table first. Based on this table, we use this table to plot our graph. So also for this second part of the equation, that is x minus y equals to 3. So here, let's see. We make, this is table 1. Table 1. So this is table 1. So here, table 1, we need to have 3 points to consider here. So the first one, yeah, let's say, here we can say x, the second point we can say y, then this is the coordinate x, y. So from table 1 here, you see, now we just assume different variables. Mind you, this one is for x plus y equals to 6, this is for x plus y equals to 6. So now this one we can assume any numbers, let's say, but make sure the numbers you are going to let is not a fraction, okay? So here we can start from 0, 1, 0, 2, 4, 6. So we have here we let x to be 0, 2, 4, and 6. You can take any number. You can say let x be 1, 2, 3, and 4. You can let any number, okay? So here we let x to be 0, 2, 4, and 6. So now, in order for us to find our y coordinates, first we use this equation where we said x plus y equals to 6. Here we say x plus y equals to 6. Okay, so when x is 0, when x equals to 0, then we substitute x to this equation. This is our first equation. We substitute x to this equation, so 0 plus y equals to 6. So therefore, our y is equals to 6. So now we add here, our y here is 6. So our coordinates here will be 0, 6. So then again, we call for this when x equals to 2. When x equals to 2, we substitute 2 into this equation, then we find our y. So now we say 2 plus y equals to 6. So therefore, our y is equals to, when we transpose this, 6 minus 2 is 4. So this is 4. So therefore, our coordinates here, y here is 4. Our coordinates here is 2, 4. Then the third one, when x equals to 4, when x equals to 4, again we substitute. So we say 4 plus y equals to 6. Therefore, our y coordinate will be 6 minus 4, which is 2. Then finally, so here we have 2, here we have 4, 2. Finally, the last one, when x equals to 6, when x equals to 6, what is our y? So we say 6 plus y equals to 6. Therefore, our y here is equals to 0. So this is 0, therefore 6, 0. So this is the first table, table 1. So now let's plot again table 2. First, let's try to solve for table 2, then we plot our graph. So table 2 is x minus y equals to 3. So we say table 2. We use the same method. This again we can let. Here let's say here we can say 1, 2, 3, 4. So this we have our x, y, x, y. So now, okay, so now let's say our equation here is x minus y equals to 3. So x minus y equals to 3. So let x, this one x starts from 1, say 2, 3, and 4. So let's see here again. The same procedures apply here. So we can say when x equals to 1, so now we say 1 minus y from this equation, 1 minus y equals to 3. Therefore, 1 minus y equals to 3. If we transpose this one, now you can transpose this, become 1 minus 3, which is minus 2. Or if we transpose the y here, this y becomes minus 2. Okay? Well, this one will come, then this will come here, minus or you can also say minus y equals to 3 minus 1 minus y equals to 2. So we divide both sides by minus 1, then y equals to minus 2. So it's the same. So when x equals to 1, y is minus 2. So when x equals to 2, so when x equals to 2, when x equals to 2, therefore we say 2 minus y equals to 3. Our y now becomes, we transpose this again, we use the same method, we say y now is equals to 3, or we say minus y equals to 3 minus 2, so that you will not see it out. So y equals to minus 1. Because 3 minus 2 is 1, then we divide both sides by minus, this is minus 1. So let's see this. We need to increase this so that we'll be working everything here. So when x equals to 3, when x equals to 3, we say 3 minus y equals to 3. So now we say this minus y equals to 3 minus 3, which is 0. So this one is 0. So y here equals to 0. So when x equals to 4, when x equals to 4, when x equals to 4, now we say here 4 minus y equals to 3. So here now minus y is equals to 3 minus 4, which is minus 1. 3 minus 4 is minus 1. So therefore our y here is equals to 1. So y here equals to 1. So now the coordinates are this 1, minus 2, 1, minus 2, 2, minus 1, and 3, 0, and 4, 1. So now we can use, now as you can see here on the board, we have two tables. The first table is for the first equation, then the second table is for the second equation. So now we are going to plot our graph using these coordinates here for the first equation. So now we use a scale of 1 centimeter to 1 unit. Yeah, it's okay, but for the x-axis, for this first one, you can use 2 centimeter to 2 units. You can just use any scale that is comfortable for you. So here, let's see, scale. Scale, let's say 2 centimeter to 2 units. 2 units. So the scale is 2 centimeter to 2 units. So now let's draw our graph here and see. So let's say this is our axis, x and y axis. This is our x and y axis. So as we said, we use 2 centimeter to 2 units because of space here. So when we use 2 centimeter to 2 units, we say 2, 4, 6. This is 2, 4, 6. This is 2, 4, then 6. This again is 2, 4, then 6. So let's see here. So this is 2, 4, 6. So again is 2, 4, 6. 2, 4, 6. 2, 4, 6. one here is negative. It's negative, and this again is negative. So now let's see. So first, we'll consider this first table. When we consider this first table here, you can see for table 1, where the equation is x plus y equals to 6. For x plus y equals to 6, these are the coordinates we are going to use to plot this graph. So this, when x is 0, when x is 0, y is 6. So when x here is 0, this is our 0 position. When x is 0, y is 6. So we plot here. So when x is 0, y is 6. So now when x is 2, y is 4. You see here, when x is 2, y is 4. So when x is 2 here, y is 4. So we trace this one, this point. You see here, this is our point. And again, when x is 4, y is 2. When x is 4 here, y is 2. Is 2. This is another point. Then when x is 6, y is 0. When x is 6 here, y is 0. So this is the point. So now what we do, we try to trace this line. We trace this line here. So you can see this. You can trace this, join this point. This graph. You can label, don't forget to label, this is your y, and this is your x axis, y axis, and this is x axis. So this equation, the equation of this one is x plus y equals to 6. This is x plus y equals to 6. Then now we are done with this first equation. So now let's see for the second table. We have again here another coordinate. We have 1, minus 2. When x is 1, y is minus 2. So here again, when x is 1, so 1 is between here. When x is 1, y is minus 2. So here we trace. These are minus 2. So when x is 2, y is minus 1. When x is 2, y is minus 1. So this is our minus 1. Point between this and this. So this again. No. Again, we can label our points here. We can label our points here. This is 0. This point you can say 0, 0, 6. Then this again you can say 2, 4 coordinates. This you can say 4, 2. Then this you can say 0, 6. So this now is 1, minus 2. These are coordinates. And this is 2, minus 1. So let's see the other points. The other point is 3, 0. When x is 3, y is 0. So when x is 3, y is 0 is between here. So this 3, 0. 3, 0 for this. Then when x is 4, y is 1. So when x is 4, y is 1, this is between here. This is between here. So this 4, 1. So this is the point. Then again, we try to draw this graph. We trace this one here, this line, this points. We trace all these points here, and we see. These are the points. So this equation is the second equation, that's x minus y equals to 3. X minus y equals to 3. So if we plot this graph, we use graph papers, then you can get exactly. So this point of intersection here, The point of intersection here, this point here is the solution of the equation. So this is the solution of the equation. Solution of the equation. Solution of the equation. So now we can trace these points, these 2 points, where these 2 lines intersect, the 2 equations intersect here, this and this one. So let's say this is between 4 points. You can say 4.3 for the x. You can say 4.5, 4.5, then you can say, or can even say, maybe this one will fall between 5, then this will fall between 1.7, 1.5 again, 1.5. So therefore, the solution of this equation is 4.5 and 1.5. This point of intersection, this y is 1.5. Just assume this approximates. Then this is 4.5. So now, here we have another equation here on the board. So what I want you to do, just pause the video here, then try to solve this equation, then we'll solve it together. We'll try to solve it together again.